This question is a little bit different because we have to do a little work to put it into the correct form. So we will start by distributing the x to both values in the binomial. So 2x squared plus x equals 15. Remember that we like to have all of those terms on one side and equal to 0. So I'm going to subtract 15 from each side, which is going to give me 2x squared plus x minus 15 equals 0. Now, I can't factor this by looking for numbers that multiply to 15 that subtract to 1. And the reason that I can't is because in this case my a value is not 1. So when my a value is not 1 and I cannot take it out as a GCF, meaning I can't divide each term by 2, that means I'm going to have to do something called tic-tac-toe factoring. I believe Alex teaches a similar method, but they call it the AC method. If you like that way better, you are certainly welcome to use that way. I like this way because when I was taught how to do it way back in the day, I just had to guess and check, and that was a very lengthy and tedious process. So to set up tic-tac-toe, I'm going to make a tic-tac-toe board like so and put a little box on the bottom right. And in the first box, I'm going to write my first term. And in the second box, I'm going to write my last term. So when Alex uses the AC method, this is what they're doing. They're taking a times c just as I'm doing. 2x squared times negative 15 is negative 30x squared. I'm going to write my b value in the bottom box, and you can write it with the 1 or without the 1. It doesn't matter. If it's a number like 3 or 4, of course you would write it. Now I'm looking for numbers that are going to multiply to this value that are going to, in this case, subtract, so it's add or subtract to this value. So in this case, I'm looking for numbers that multiply to negative 30 that have a difference of 1, which would of course be 5 and 6. Now, in order for them to add to positive 1, the 5 must be negative, and then of course that would explain why my product is negative. Once I get to this point, now I'm looking for numbers that multiply to negative 5x. The sign will always go in this row. So this would be the negative here, and this would be a positive here. So multiplying to 5x, I would use 1 and 5, but I couldn't put a 5 here because 5 doesn't go into 2. I would put a 5 in this column because 5 does go into 15. In order to determine what number goes here, I would ask what number times negative 5 is 15, and that's positive 3. On this side, then, again, I'm looking for what number would I multiply by negative 5 to get negative 5x. That would just be 1x. And what number would I multiply by 3 to get to 6x, and that would be 2x. And then my answers, or my solutions, are 2x minus 5, because that was this diagonal, and x plus 3, again equal to 0. So now that I have factored, now I will solve by setting each of those equal to 0. Again, whatever math you're able to do in your head is fine. Not the factoring, obviously, I need to see the factorization. But in order to find the zeros, again, you can show that work or you can do it in your head. The first one would be 5 halves, which I would leave as 5 halves, and the other would be negative 3. So my two solutions would be 5 halves and negative 3. Now, I've heard from many of my students that I hate tic-tac-toe. I would rather do it another way. So here is one other way that you can do a tic-tac-toe type of question. Notice it's the same question. Remember, we did turn this into 2x squared plus x minus 15 equals 0. So this is the way that I believe Alex will show you how to do it. When you factor something like this, the first thing you will do is to find a times c. So I would take 2 times negative 15, which is negative 30. I would then look for numbers that multiply to negative 30. So again, I could make my little table. 1 times 30, 2 times 15, 3 times 10, 5 times 6, and I'm looking then for numbers with a difference of 1. So of course that would be the 5 and the 6. Now I need them to have a difference of positive 1, which gives me a minus 5, and a plus 6. So what I would do then, using this new method, is I would write this as 2x squared, and then it doesn't matter the order that you put these in. You could put the minus 5 first or the plus 6 first. I'm going to put minus 5x plus 6x minus 15 equals 0. So what I've done is I've just separated positive 1x into a minus 5 and a plus 6. Again, it doesn't matter the order. You could flip-flop those. And then I would factor this by grouping. So if you're familiar with factoring by grouping, which we reviewed already together, I would find the GCF of these two terms, which is x, and write what's left over when I factor out the x. I would relieve that plus sign. I would find the GCF of these two terms, which is 3, and then write what's left over when I divide each by 3. And notice what happens is these two are the same, and so my factorization is x plus 3, 2x minus 5, and of course set each of those equal to 0. I get the question then, what if I would have done this backwards and put the 6 first? So let's show you that real quick. I would have had 2x squared plus 6x minus 5x minus 15 equals 0. Again, I would combine or factor by grouping. GCF here would be 2x, which would leave me with x plus 3. GCF here would be that minus from here, 5, and then x plus 3, because if I'm taking out a negative, that would make that positive. And then, of course, that would leave me with 2x minus 5, x plus 3, which is the same. And then again, on either of these, I would set both of the factors equal to 0 and get negative 3 and positive 5/2, just as I did before. So if you prefer this way to tic-tac-toe factoring, that works for me also. Since this video is already so incredibly long because I wanted to go through all of the different ways to factor with you, I didn't put any individual practice in there. You'll get lots of that in Alex, but please do use that cheat sheet that I provided for you to help you out. The upcoming lessons deal with different ways to solve. We've already talked about, obviously, by factoring. The upcoming ways are the square root property, completing the square, and the quadratic formula. So I wanted to just provide for you a template as to when to use which one. I prefer factoring, but not all quadratics are factorable. So if it's easily factorable, I tend to factor if I'm trying to solve a quadratic. The square root property, which you'll learn next, we use only when b is 0, meaning it's going to look something like this, which we just did a question like this by factoring. This would be solving this using square root property, which is coming up. Completing the square is best when b is an even number, so when that middle value is even. Otherwise you deal with a lot of fractions, which are not fun. The quadratic formula is awesome because it always, always, always works. And once you learn it, it'll just get stuck in your brain and you can just use it all of the time. It's especially helpful because it works even when the solutions are imaginary, which will obviously happen sometimes.